Hey, what is up guys? Welcome back to another YouTube video at the World of AI. In today's video, we're going to be showcasing a new open source project by Microsoft Research, and that is called Orca. It's a progressive learning project from the complex explanation traces of GPT-4. Now, in this video, we'll delve into the new research paper, which focuses and introduces an innovative technique for training open source models. Now, this is quite remarkable, guys, because we're able to see that there's open source projects that are slowly but surely getting closer to GPT 3.5 as well as GPT 4 types of results. We can see in this tweet right here that it's surprisingly capable of reaching GPT 3.5 turbo results in terms of its performance capabilities, and it's basically able to do this by computing with no internet actual connection, as well as about 8 gigabytes of hard drive space. And this is quite astonishing because we're able to surely get to this open source model that can compete with ChatGPT's 3.5 models as well as GPT-4 models. And slowly but surely we're able to see that there's going to be a time where we're getting closer to this point where open source models can be able to actually compete with these different types of GPT 3.5 models. Now, this technique presents a significant advancement by enabling small models with a size of 13 billion parameters to go beyond merely imitating large foundational models such as GPT 3.5. And this is why we're going to be showcasing this project as well as this research paper. Now, the paper introduces a novel approach that empowers these smaller models to acquire reasoning capabilities as well as which helps them enable them to understand and demonstrate the underlying thought process behind arriving towards a solution. Now, this breakthrough is a notable step forward in the field of machine learning as it showcases the enhancements of models' capabilities that can go beyond the patterns recognition. Now, by incorporating this new training technique, the researchers at Microsoft Research have been able to bridge the gap between large foundational models and smaller models, which enables the latter reasoning capabilities similar to large counterparts. And basically, with this development, we're able to see that it opens up a new possibility for smaller models to tackle complex tasks and provide more insightful responses for different types of generative content. And this is something that we'll slowly but surely showcase in this video. We're going to talk a little bit about the data that is used to create this project, as well as taking a look more as to what you can do with this, as well as taking a look at the experiments of this project. And with that thought, guys, before we delve deep into this project, it would mean the whole world to me if you guys can go give the Twitter page of World of AI a follow. I'm going to be posting the latest AI news over here. Now, if you guys haven't subscribed, please do so. Turn on the notification bell, like this video. And firstly, I just want to say I am so sorry for not uploading for the last few days. You can see there's been a trend where I haven't been uploading daily after this 2-week mark. It's been really busy in June, guys. I've been really hectic with a lot of different projects as well as a lot of different things. So I'm gonna try my best to upload daily, but at this rate, I don't think I'll be able to do so within this month. I just want to tell you guys and be honest, because I'm not going to be able to work towards putting out videos because I have a lot of important stuff on my end that I need to complete. But once that is done, usually around in July, I'll be more free to upload back to my regular schedule where I upload 2 videos a day. And with that thought, guys, let's get right into the video. Now, let's take a look at this figure in the introduction. Now, in figure 1, there's the context of Orca's research project, which demonstrates the superior performance of Orca. Now, this is just simply a 13 billion parameter model of Orca being compared to various foundational models, including OpenAI's ChatGPT 3.5 as well as GPT-4. Now, this evaluation is conducted using Vicuna's evaluation set. Now, the results indicate that Orca is outperforming these foundational models in terms of its performance and accuracy on specific evaluation sets. Now, additionally to this, what the paper is showcasing is that there's a similar favorable outcome when testing Orca against evaluation sets used in other research works. It indicates that there's general effectiveness across different scenarios. Now, moving on to the second figure, we can see that it focuses more on the concept of explanation tuning with Orca. Now, again, it utilizes a model with 13 billion parameter like the figure 1 we showcased. And basically this objective is to close the performance gap between Orca as well as the foundational models like Text Da Vinci or like different ones such as ChatGPT and Vicuna 13b. And basically we're able to see that it's closing the gap with these different types of model. Now, the evaluation is carried out with a diverse range of professional and academic exams such as LSATs as well as SATs, GMAT, etc. And notably, this is an evaluation that is conducted in a zero-shot setting, meaning that there's no type of conversation on the topic data that is used to aid the model's performance. Now, the results presented in this figure are indicating that Orca achieves a significant progression in closing the performance gap with the foundational models of these different types of LLMs over here. Now, specifically in comparison to ChatGPT, Orca was able to demonstrate a reduction in the performance gap by 5 points, and furthermore, it should be noted that the gap further diminishes when the system message are optimized, and this suggests that the Orca's explanation tuning capabilities are able to enhance its performance on professional and academic exams, which is kind of showcasing that it can enable it to achieve competitive results without the need for explicit training as well as specific exam result data. Now, this is quite remarkable, guys, because you can see that you're able to train smaller models on lower data sets, which can help you outperform or become you're able to be competitive with these larger models, which is quite amazing, as it showcases that you're going to be able to efficiently and effectively train different types of models. And this is something that we'll surely showcase later on in the video. Now, before we actually go more deep in depth with the other stuff in the video, where we talk a little bit more about the actual analysis as well as the experiments, I wanted to talk about the challenges with existing models. Now, for now, there's a problem with which we can see with existing models, which is interpretability and explainability in complex machine learning models. And these are some of the several challenges that are faced with these existing models. And these challenges include the increasing complexity of models, which show that there's a lack of transparency in decision-making processes and a difficulty in understanding the underlying relationships between the inputs and the outputs. Now, additionally to this, there's a limited interpretability, which hinders the identification of biases, errors, and areas of uncertainty within the model. Now, the need for this method can be addressed with challenges that are crucial to enhance the trust, the transparency, and accountability in the deployment of complex machine learning models across various domains. And this is something that they've noted down with the Microsoft researchers which are working on this project as some of the challenges with existing methods of the actual models that exist. In this research paper, there are primarily 4 focuses that are addressing the challenges that are mentioned above. And firstly, we're going to talk about the progressive learning framework. Now, we introduced this novel progressive learning method at the start, which is called Orca, and it's basically designed to enhance the interpretability and the explainability in complex machine learning models. Now, this framework enables the actual method to refine its understanding by incorporating new explanation traces over time, and this is by accumulating and analyzing a diverse range of explanation traces. And with Orca, you're able to see that there's a progressive adaptation and work towards improving its interpretation of complex systems. And this is one of the key contributions to actually working towards the challenges of existing models. Secondly, there's a complex explanation traces of emphasizing that it works towards the importance of complex explanation traces and understanding the decision-making process of different types of models. And these traces basically provide a detailed record of the model's internal operations, which focuses on including the data flow of computation and decision outcomes. Now, by leveraging these traces, Orca captures the actual relationship between the inputs as well as the actual outputs that are used within the model. And what this actually does is that enables a deeper understanding of the model's behavior. Now, a third contribution is the actual enhancements of its interpretability. And through the use of Orca, we're able to see that there's a progressive learning and a complex explanation traces, which are used to demonstrate the distinguished improvements of the interpretability of complex machine learning models. Now, the insights that are gained from accumulated explanation traces helps enable to identify important features, which helps understand decision boundaries, as well as highlighting areas of uncertainty and biases within the actual model. Now, this interpretability enhancement contributes to the building trust and understanding in decision-making processes of these models. Lastly, the last key contribution is the comparative performance evaluation. Now, with Orca, it provides a comprehensive comparative evaluation that is against various foundation models, which we showcased above in this table. And basically, the evaluations demonstrate that Orca is able to outperform these models in terms of accuracy, performance, and interpretability on different evaluation sets as well as benchmarks. Now, this comparative analysis highlights the effectiveness and robustness of Orca in complex scenarios. And by addressing these challenges that we talked about, we're able to see that there is an introduction towards the progressive learning framework, which emphasizes a solution for complex explanation traces and enhancing interpretability and conducting through performance evaluations. Now, in table 1, we're able to see that it overviews the popular models that have been actually used for instruction tuned with OpenAI's large foundational models. Now, these LFMs serve as a basis for comparison in the context of Orca. In contrast to these models, Orca has been able to leverage complex instruction and explanation for progressive learning, and by utilizing detailed and comprehensive explanations, Orca was able to enhance its learning process and improving its interpretability. Now, this approach showcases that Orca's a part of different types of models that rely solely on instruction tuning, which showcases the unique contribution and effectiveness of Orca in the domain interpretability of machine learning. In figure 4, we're able to see that it illustrates the process of instruction tuning with GPT-4. In this approach, where the system takes the user instruction for a specific task along with the input and generates an appropriate response. Now, existing works such as Alpaca, Vicuna, as well as their variants follow a similar template for training smaller models, and they utilize the training data in the format of user instruction, input, as well as output to fine-tune these models. Now, instruction tuning involves training the models to understand and follow user instruction in order to generate accurate and contextual appropriate responses. Now, by incorporating both the user instruction and the input, these models tend to aim to capture the desired behavior or responses from the system. Now, we can see over here that Alpaca, Vicuna, as well as similar approaches that have been utilized to train smaller models, leverage the instruction tuning techniques to improve the performance of effectiveness of these smaller models. Now, by training on specific user instructions as well as associated inputs, these models can learn to generate responses that align with the intended tasks or approaches. Now, in context to Orca, figure 4 is able to highlight the difference in approaches. Now, while instruction tuning with GPT-4 or GPT 3.5 relies on user instruction as well as user inputs, Orca takes a distinct path by leveraging complex instructions and explanations for progressive learning. And this is by utilizing detailed explanations in addition to its instruction. And basically, with Orca, it enhances its learning process and offers an improved interpretability, which sets it apart from models that solely rely on instruction tuning techniques. In figure 5, it depicts the process of explanation tuning with GPT-4. Now, this approach involves not only user instructions and inputs, but also system instructions, which guides the system to generate well-reasoned and coherent responses. Now, the system instructions are sampled from a diverse set that includes a chain of thought reasoning steps, as well as explaining like I'm 5. Now, being helpful, which shows other relevant structures of this model. Now, by incorporating these rich and well-structured instructions, smaller models that can be tuned to mimic and thinking processes of GPT-4 can be paired with Orca. Now, explanation tuning with GPT-4 aims to enhance the quality as well as the coherence of responses generated by smaller models. Providing an explicit system instruction, these models are guided to produce well-reasoned as well as contextual appropriate outputs. These systems have been able to showcase that there's instruction contributions to capture the thinking process as well as the reasoning abilities of larger GPT-4 models by utilizing Orca. Lastly, I want to emphasize a little bit more on the explanation tuning, and we'll end off this video by showcasing a couple examples of what you can do in terms of Orca in comparison to different types of models such as GPT 3.5 Turbo as well as GPT-4. Now, we talked about training before, but training plays a vital role in the development and the deployment of Orca, and this section basically showcases an importance that overviews the training process, including tokenization and sequencing, as well as loss computation. Now, tokenization in the training of Orca, as well as the Llama by-bit pair encoding tokenizer is employed to process the input examples. And this is a notable feature of Llama's tokenizer, which is an ability to split all numbers into individual inputs, as well as digits, which ensures this numerical information is appropriately representative within its data. Now, sequencing is used after tokenization, which basically focuses on the inputs examples that are organized into sequences, and basically they're suitable for training the actual model. And these sequences ensure that the information is properly structured and can be effectively processed by the model during the training phase. And lastly, there is the focus of loss computation, and this is during the training process where the model performance is evaluated through a computation of loss, and the loss is basically a function that quantifies the discrepancy between the predicted output of the model as well as the desired outputs. Now, the experiments conducted by Orca to evaluate its performance were conducted in depth with a focus that provides detailed insights into its capabilities. The evaluation encompassed a variety of tasks and benchmarks that assessed Orca's language understanding, reasoning abilities, as well as its overall performance. Now, the experiments involved rigorous evaluations as well as protocols that considered different abilities, including writing, comprehension, analytical, mathematical, as well as logical reasoning. Now, various datasets and benchmarks are actually utilized to provide a comprehensive evaluation of Orca's ability to showcase its performance across different domains. Now, for writing abilities, we're able to see later on in the actual research paper that it showcases its evaluation where Orca's responses were assessed by coherence, contextual relevance, as well as overall quality. And this is something that was compared with different types of large models such as GPT 3.4, as well as, not 3.4, 3.5 and GPT-4. And the model's proficiency in generating well-structured and informative responses that were thoroughly examined with this comparison. Now, in terms of its comprehension, the Orca's understanding of complex textual information as well as its ability to accurately interpret and respond to comprehensive-based questions were assessed, and this evaluation was aimed to measure the model's comprehension on terms of its skills and its capabilities to derive relevant information from given tasks. Now, if you want to get more information on these types of experiments, if you scroll down a little bit to the end, you're able to get a better understanding of these different types of responses that were compared with different larger models such as Vicuna, GPT-4, and etc. And we can see down over here, there's temporarily a section that focuses on the types of comprehensive as well as the performances across different domains such as math, and as well as the different things that we talked about before. And with that thought, this concludes today's video on this new amazing project of Orca. I hope you got some sort of value out of this research paper. This is something that I will be showcasing later on as they continuously work towards improving, as well as incorporating different innovative tactics to improve this research paper. And with that thought, guys, thank you so much for watching. I hope you got some sort of value out of this. If you guys haven't followed the Twitter page, please do so. If you haven't, turn on the notification bell, subscribe, like this video. If you guys haven't seen any of my previous videos, I highly recommend that you do so. And with that thought, thank you so much for watching. I'll see you guys next time. Peace out, fellas.